Welcome to 2.6 Ratios, Rates, and Conversions. Let's begin by talking about some definitions. The first definition I want to talk to you guys about is a ratio. A ratio compares two numbers by division. Two numbers compared by division. So let's say an example, we have two numbers A and B, where B is not equal to 0, and there's a very important reason why B can't be 0. That's because we're never allowed to divide by 0. But if we have two numbers, say two numbers A and B, and we want to compare or we want to make a ratio rather, there are three ways that we could do it. We could say A over B, that would be a ratio of A to B. The second way we could do it is we could use A dot dot B, so A colon B. Or we can actually just write the words A to B. So this is a ratio comparing two numbers by division. Most of the time, you will see me using option number 1 because that's the definition comparison of two numbers by division. That's the first definition I want to talk about. The second definition I want to talk about is a rate. And a rate is a ratio that compares quantities measured in different units. So here's some examples of rates that you guys might be familiar with. Miles per hour, this is a rate. And the reason this is a rate is because it's a ratio, right? It's a comparison through division, comparing two quantities that are different. I have miles and I have hours. So it's considered a rate. A second one is, seconds per minute. I have seconds and then I have minutes, and it is a ratio because it's a comparison of two things by division. And I have days per week. Here's another rate. So a rate is nothing more than a ratio that compares quantities measured in different units. That's the key part, different units. The third definition I want to talk about is a unit rate. And a unit rate is nothing more than a rate with a denominator of 1 unit. As an example, 60 seconds for 1 minute is a unit rate. 7 days per 1 week is a unit rate because my denominator is of 1 unit. We're going to use these in the examples above. Let's do an example together in box number 2. It's because shopping. You're shopping for t-shirts. Which store offers the best deal? You have store A, which gives you $25 for 2 t-shirts. Store B, $45 for 4 t-shirts. Or store C, $30 for 3 t-shirts. So what we want to do is we want to create a ratio. So store A is going to be $25 for 2 shirts. So we want to compare dollars to shirts. Store B is going to give us $45 for 4 shirts. So again, I'm comparing dollars per shirt. And store C is going to give us $30 for 3 shirts. So we want to actually take this consideration and do it by division. So 25 divided by 2 gives us a price of $12.50 for every 1 shirt. So I have a unit rate. I have $12.50 for 1 shirt, and this is coming from store A. $45 for 4 shirts gives me a value of $11.25 for every 1 shirt. So my unit rate for store B is going to be $4.50 divided by 4, which is $11.25. And then take a look at store C. We have $30 for 3 shirts. So if I take $30 divided by 3, obviously we would get $10 for every 1 shirt. So now that I am comparing all of the same prices for every 1 shirt, it's pretty obvious to me that store C gives us the best deal because we're only paying $10 for a shirt versus $11.25 or $12.50 for a shirt. That's what we mean by a unit rate. Box number 3 is going to explain how to convert from one unit to another. In order to do this, we multiply the original unit by a conversion factor that produces the desired unit. So a conversion factor then is a ratio of two equivalent measures in different units. So let me say that again. To convert from one to another, you're going to have to multiply by the original unit, whichever one that is, the original unit, by a conversion factor. And a conversion factor is a ratio of two equivalent measures of different units. Let me give you an example of what we mean by this, okay? So 330 minutes is how many hours? So here's what we've been given and here's what we know. We know, okay, we want 330 minutes Okay, and we are looking to convert it into hours. So we have to multiply by a conversion factor, and that conversion factor is this. We know that 1 hour is worth 60 minutes. This is our conversion factor. It is a ratio of two equivalent measures for different units, right? So an hour is worth 60 minutes. They're equivalent, right? But they have different units. One's hours, one's minutes. That's what makes it a conversion factor. So now, what's this is so nice is because look, my minutes cancel out in my denominators, or my denominator over here on the right, and then minutes. So that tells me that all I have left with is hours, and that's the desired unit. That's what I mean by here, to produce the desired unit. The desired unit is hours, so that's all I have left with. So all I have to do now is just take 330 and divide it by 60, because that's what this says. This is like 330 over 1, and I'm just multiplying straight across. And 330 divided by 60 gives us 5.5, and we're talking about hours. So we have now converted 330 minutes to hours. In box number 4, this is your first you try for this lesson. 15 kilograms is how many grams? So I want you to convert from 15 kilograms into grams. Remember, there are 1,000 grams for every 1 kilogram. Hopefully you got the right answer of 15,000 grams. If not, here's how you do it. We start with 15 kilograms and we multiply by the conversion factor of 1,000 grams for every 1 kilogram. Notice that the kilograms cancel out in units and you are left with just grams. So we multiply 15 times 1,000 and we get 15,000 grams. Box number 5 is another example. A student ran the 50-yard dash in 5.8 seconds. At what speed did the student run in miles per hour, round to the nearest tenth? Okay, so here's what we know. We know that we have that 50 yards was run in exactly 5.8 seconds. All right, and we are looking for miles per hour, so we need to keep multiplying by a conversion factor until the desired unit is achieved, and that desired unit is miles on top and hours on the bottom. So miles will be in the numerator, hours will be in the denominator. Well, here's what we do know. I know that 1 mile, okay, is worth 1,760 yards. You can Google it to see if you want to figure it out. So look what this does for me, right? This cancels out yards for yards. So now I have miles and seconds. Is that what we want? No, because we want miles per hour. So we multiply again by another conversion factor, and we know that there are 3,600 seconds for every 1 hour, right? So again, you can Google that if you need to, but look what I have. Seconds cancels out with seconds, and I am left with miles, my unit in the numerator, and hours, my unit in the denominator. So what do? We multiply all these things together. So by multiplying the numerators, I get 50 times 1 times 3,600. So this is going to equal 50 times 3,600. In the denominator, I have 5.8 times 1,760. 1,760. Well, and then times 1. So we run all that through our calculator, and you get approximately 17.6 miles per hour. So that person was running on average 17.6 miles per hour. Run that all through your calculator, make sure you get the same thing. Box number 6, the final box, is a you try. It says this: an athlete ran a sprint of 100 feet in 3.1 seconds. At what speed was the athlete running in miles per hour? Okay, so if you do a lot of converting, you have to convert from feet and seconds into miles per hour. Okay, here's the solution. Here's how I did it. I had to come up with 3 different conversion factors to figure this out, and I'll show you all of my markings in purple. So we start with 100 feet per second. I multiply that because I know that 60 seconds is 1 minute, and notice that my seconds cancel out. Then I convert from seconds to minutes, from minutes to hours, by multiplying by their 60 minutes. in 1 hour, so my minutes now cancel. And then I have 1 mile is worth 5,280 feet. So feet from the original 100 feet cancels out with feet at the bottom. And notice that my units that I have left with on the top, everything that's not canceled is miles. On the bottom, everything that's not canceled is hours, and that's what I want, miles per hour. So each of these pieces, this one, and this one, are your conversion factors. So multiplying the numerators together, I have 100 times 60 times 60, all divided by 3.1 times 5,280. I ran it through my calculator and I got about 22 miles per hour.